All right, so let's work this problem. We've done a few of these now. Hopefully we're getting the hang of it. So now we're looking at the influence line for the moment at C. So just to let you see where this is, I'll emphasize it. There's point C. So I'm going to have to cut it here to find the moment at C. Do you want to work the left side or the right side?
Left.
Left. Good call. So when I do that, I'm going to need what? The reaction at A. So let's do that first. So I'll draw a free body diagram for the structure. And I will assume that I have AY acting up and BY acting up. And then somewhere on this structure is my moving load with a distance of X from the left side. And since we've already decided we want to work the left side, and that requires the reaction at A, I want to find the reaction at A for this moving load. So how do I do that? Some moments about where? B. B. So let's do that. So I'm going to sum moments about B, make sure the structure is in equilibrium. I'm assuming right-hand rule. So when I go the distance from B to that unit load, what's that going to be? Well, this distance is 10, and this distance is 5. So what's that distance going to be right there? 10 minus X. From here to there. Everybody see that? So when I'm summing moments about B, this creates what kind of moment? Positive or negative? Positive. So it'll be 1 times a moment arm of 10 minus X. Then AY creates what kind of moment about B?
Negative.
Negative. So that'll be negative. AY is the force. And what's the moment arm? 10. So solve for AY. And you get 1 minus X over 10. Okay, so what's next? What do I do next? I guess I'll go ahead and plot that just so you can see it. So here's AY as a function of the unit load moving, and that will be at this distance, this distance. So what will we get? When you put in X equals 0, you get 1. When you put in X equal 10, you get 0. When you put in X equal 15, what do you get? Nope. Negative 1/2. So as the unit load goes past B to the right-hand side and pushes down, AY has to change signs and pull down to balance it. So that's why you get a negative value. So now I'm going to cut my structure. And the first case I'll look at is when the unit load is between 0 and 5. That means it's going to be on this free body. So if I draw that, there's my free body diagram with a distance of 5. I've got my A reaction, which is 1 minus X over 10. I'm going to solve for my moment at C. That's positive bending moment. And then I'll have my unit load at some position X. So what's the distance here from the cut to the unit load? 5 minus X. So I think I have all the pieces I need, right? So I'll assume right-hand rule for sine, and we will sum moments at the cut, which I made at 5 meters, and what do I get? I get my internal moment C, that's positive. My unit load creates what kind of moment about the cut? Positive or negative? Positive, so that'll be 1 times a moment arm of X minus 5. And then I have this guy, my reaction, with a value of 1 minus x over 10, that is what? Positive or negative moment? Negative. So that's 1 minus x over 10 is the force. And what's the moment arm? 5. So let's solve for the moment at C. Let's see, what do I get? I've got, there's positive 5, there's negative 5, so that cancels. Right? Here's negative x, here's positive x over 2. So it looks like I get x over 2. Algebra. Mind-blowing, isn't it?
Yes.
Is that good? Everybody see that? So we do it again. This time between 5 and 15. That's the position of the unit load. Our free body diagram is identical. It's still 5 feet. We're still looking at the left side. The reaction at A is still 1 minus x over 10. The internal moment is still considered positive, except there is no unit load. Why? Because it's between 5 and 15. Has left. Elvis has left the building. Unit load has left the beam. That's it. So what do I do? Sum moments. So I'll use right-hand rule for sine. I'll sum my moments at the cut. I'll set an equilibrium. So I start off with my internal moment, which is positive. And this reaction creates negative moment. Has a value of 1 minus x over 10. That's the force, and the distance is 5. So it looks like my moment at C is just going to be 5 minus x over 2.
It turns to
Algebra. So all I do is plot those things. So let's see what we get. So my ordinate will be the moment at C as it varies across the structure for the unit load. So I'll go ahead and kind of sketch that in. So from 0, let's bring this in too, point C, which is kind of right in the middle. So for 0 to 5, I plot this, x over 2. So when x is 0, I get 0. When x is 5, I get 5 over 2. And that's a linear line. From 5 to 15, I have to plot this curve. So I start off with 5. I get 5 minus 5 over 2 is 5 over 2. So you won't see discontinuity there. It's got to come back to be the same value. And then I'll check it at 10. 5 minus 10 over 2 is 0. And then I'll put 15 in there, and 5 minus 15 over 2 is minus 5 over 2. So there's my influence line for the moment at C. What's the greatest moment created at C? Well, it depends on the sign. You'll be here, right at C, you'll create a maximum positive moment. But all the way out here at 15, I'll create a maximum negative moment at C. Now, if you're doing reinforced concrete designs, this is important. Because as the load moves across the structure, that point at C will vary between positive and negative moment. In fact, it'll go back and forth. It will vibrate back and forth. So you have to design your reinforced concrete structure to handle both tension in the top face for the negative moment and in the bottom face for positive moment. Yeah.
I have a question. At the beginning of when you're finding the momentum at B, why did you use 10 minus x for BC? I still don't get that.
Where are you? Oh,
Finding
up
the
here.
momentum at B.
So I wanted the distance from B to the load. So this distance is 10. This distance is x. So the maximum minus what I have, it tells me what I have left over. 10 minus x.
And why did you put the load right there?
I just did. It can be anywhere. It can be at any position x.
But not past it.
Oh, you can go past. Sure,
Could it be at the right of
What
B?
happens to this when x is 15? You get minus 5, which is over here.
Oh, yeah.
So it takes care of it. It takes care of the sign. Because about B, this is creating positive moment, but when it gets over here, it's going to create negative moment. But the distance will change signs. So it'll take care of it. Pretty cool, huh? Are you guys liking this stuff yet?
So far.
All right.